Okay, welcome and enjoy seeing the how we are going to do the repair of this motor. But before we begin, I'd like to take you through what it is being required so that you'll be able to do the motor repair comfortably without having any issue or any technical challenge. Before we do that, I'll show you a number of items which are required so that you'll be able to do the motor repair. So this motor came from a customer, and I'd like us to go through. We see what it is going, what is the problem with this motor. Then we repair together, step by step. So in today's video, I'll just show you how to begin. So before we do anything, these are the tools and equipment which are required so that we'll be able to do the repair adequately and very well. Now this is a digital meter, although it is very old, but it has really served me for a very long time. This is around 20 years old. I've been using for the last 20 years. So you should acquire yours also, so that you'll be able to do these repairs. Without these tools, you will not be able to do the repairs as it is supposed to be. So therefore, get to acquire one for your own. This one, it is 20 years old and it is still serving me the purpose up to now. So before we do anything, you need to do the diagnosis. You do the diagnosis and see actually what could be the problem. So this motor, as you can see, it is rotating. So before you start dismantling anything, you need to know where to start from. So this motor, it is rotating, meaning that there is no restriction, or there is nothing which is blocking it, and therefore we begin by taking the measurements. So before we start dismantling, you open the digital meter and you put on the electrical resistance. So this is the electrical resistance. It is multi-tester, so it means it is able to test so many things at the same time. So therefore you take to the lowest range of measuring resistance, ohms. So you look at the sign ohms, so you take to the lowest range. Then you look at the wires. So inside the motor are wires which are wound. So they are wound, as we shall be able to open and see. They are wound inside, and so therefore, being a wire or being electrical wires, then therefore it must be having some resistance. So inside here there is a coil, and that coil, it makes and it forms some electrical resistance. So that's why we test to measure and see whether there is some electrical resistance. So we begin by looking at the terminal box here. So the terminal box has been removed. The customer came without a terminal box, so it has been removed. And when you look at the terminals, we have several terminals. This is U1, that is U2. You need to see the way it has been arranged before you do anything. So at times also you will even take even a video or photos, so that you'll be able to know the way you are going to input. So we have two sets of windings, so that's why we have several wires here. So the first two windings, which is U1 and U2, those are known as the main windings, and they are the running windings. Then we have two other sets of windings, which are known as auxiliary winding, or they are also the starting windings. So these starting windings, when you look at as we shall look at them, the wires are thin, while the running or main windings, the wires are thick. So it is, whenever you open, you'll be able to see and you'll be able to tell which winding is which winding. So what I would like us to do now is to try to measure and see whether there is open circuit or there's a short circuit, or whichever the case. So therefore, with my multi-tester, I have put in the range of ohms. So when I just showed the two terminals like this of the tester, you'll be able to see it is just showing the resistance which is going to show 0. It's going to show 0, 0, 0, 0. So meaning that it is continuous. It means the current is able to flow. So therefore, we now test with the terminals. So when you test the terminals here, it shows that it is 0, 0, which means either it is going to be, the current is going to be continuous, or it is having a short circuit. So either it is a good circuit or it might be a bad circuit. I will tell you how to do that later on. So using the smallest range, so like for this case, I have put the range of 200. So in the range of 200, when you look at the resistance here, it is just showing 0, 0, 0.1, 0.2 there. So it is because of also the meter needs to be adjusted so that it is going to show you 0, 0. So therefore, with that range, you'll be able to know this small resistance. So when I just put like that, now it is just telling me it is 1.2, 1.3. So meaning what? Actually 1.2 ohms. So that 1.2 ohms, it means that wire is okay. It is still okay. Then we need to, so that one was for the main windings. So for us people to test the starting winding, it is going to challenge us. It is going to challenge us if at all we are not going to loosen here. So we need to loosen here because they are normally connected. So on top here, you are able to see this piece of metallic part. So it is a conduct which is able to do. We are using these contacts when we are reversing the direction of the current, and also it is to conduct through the two sets of windings. So before we test the other winding, we just unscrew or remove one of the windings here. Using, of course, I've used the pliers because the type of wrench that I have, the smallest, I don't have the smallest wrench. Otherwise, I could have used the wrench. But this wrench here, it is not as small as it is supposed to be. So you just remove it first, so that you'll be able to test. What our aim is to know actually where could be the problem. So we remove this one. After removing, we can even just remove even one. One is even enough. Then we also test now and see. So when I put the two ends, so it is just like a piece of wire. Whatever these windings is just like a piece of, it's a piece of wire, whereby we have one end and the other end. Inside here we have wires of this type, so they are wound so that you have one end of wire and the other end of wire. So therefore, whatever we are testing here, we are testing this end of wire and this end of wire. We would like to see the resistance. So because it's just a continuous wire, it's just a continuous wire. And for this case, this auxiliary winding or the starting winding, it is normally also interconnected at the back of the motor. For this case, we have a switch here, which is known as a centrifugal switch. So this switch is the switch which is normally removing one of the capacitor. This motor is 2-value capacitor motor, although the customer came with all the motors, the capacitors. One capacitor is here, which is known as running capacitor, and another capacitor here, which is known as the starting capacitor. So the starting capacitor is normally connected with the starting winding. So this starting winding, the starting capacitor need to be removed from the circuit once the motor has attained some speed. So therefore, this part here is a centrifugal switch, which normally as the motor rotates, so once it picks a speed of 75% of the rotation speed, this part here normally fly off and it releases the switch. So once it releases the switch, it leaves the it removes the one of the capacitor. So therefore, we need to test both of them and see now. So what I'm going to do is to connect the two ends of the wire here, because there are two sets of wires there inside there, so that it is going to give us, it's supposed to give us a continuous circuit from inside there. Then we try to test now. So when you try to test, still it is just showing infinite and defined. It's just showing that one there, that one is showing it is undefined or infinity, or it means there is no current, it is open circuit. So this one is just showing me that there is open circuit in the starting winding. So therefore, because there is open circuit in the starting winding, we would like to open and see. Before we go there, we also need to know whether there is a short circuit. If there is a short circuit to the body. So if there is a short circuit to the body, whenever we connect any wire or any terminal as we are testing and we connect to acting, it's also supposed to tell us whether it is there is a short circuit or there is no such short circuit. So for this case here, as when I test the running winding, it is just showing me also undefined, which means that the wire is sound. It is having no problem at all, because there is no shorting to the body. There is no shorting to the body of the motor. So therefore, we need just to remove now and get in and see what is happening inside there, so that we'll be able to know exactly what is the problem. So we have seen that the starting winding is not conducting at all. It is behaving as an open circuit. So because it's behaving as an open circuit, we need now to start opening and see. So what is going to help us do that opening is this. I'm just calling it opening because what I want to do is disassemble. So it's the disassembling of the motor. So before we do that disassembling of the motor, we need some tools which are going to help us. So with me here we have assorted tools, which are, some of them even are homemade. You can make your own at home if at all you do not have money to purchase the sophisticated tools. You can make yours at home like that. So some of them are homemade. Some of the tools they appear as if they are not actually going to help us, but they really help us. So these are the wrenches, the open open-ended wrench. Then we have the ring wrench. We have also this one is also open-ended, and we have different different sizes. So you have to look at the size of the bolt that you are going to untighten or loosen, so that you'll be able to choose the type of wrench that you are going to use. So I have not come with other types of wrenches, because from the size, the physical size of the bolt, it shows that it requires a small wrench. So that's why I have these small wrenches here. Okay, so we need now to remove the end shield. So here is known as the end shield, also here is known as the end shield, and here is the pulley. So I am supposed to remove the pulley. But now unfortunately, if I try to remove the pulley, I see there is something which has already been done with the pulley. There is welding which has been done. So I don't want to cause trouble by removing on the side of the pulley, because it will require me to go to the welding machine again, of which I do not want to go to that direction. So therefore I'll just try to remove from the other end, so that this end shield will go with the pulley, so that I skip this, because there is something which has been done with this pulley. So this thing which has been done with this pulley, I don't want to interfere with it, because otherwise, if you mess up, you'll have to replace for the customer. There are other customers which will just come and tell you, now you have to replace for me. Although we normally say, as we are doing the repair, we are repairing at the owner's risk. It's not that you are risking actually, but you need to be more careful, so that you will not be destroying instead of repairing. So therefore, we now remove from this end. Now this is known as Allen key. I want to remove the Allen key here. So unfortunately, this Allen key, it requires a smaller one. And this one is, it will not be able to remove from there. So I look for another alternative. So this one is this precision screws. I look for one which is going to help me remove that Allen key. So this one here it is. So I want to remove the centrifugal force switch now, so that as I remove the centrifugal switch, it will be able to help me remove the end shield. So that's centrifugal switch, and ensure that that one does not get lost, because you will need it after repairing the motor, or when you are assembling the motor, you will need it. So you make sure that it does not get lost. As you can see, they are very small. So that is it. Then I need to remove this one, this piece of wire, these wires, because the end shield will not come without this, removing these wires. So I look for a screwdriver, screw head, which is star, and then I just remove this one, and you ensure that the screws does not disappear, because you will need them. Otherwise, you will try to look for them and not find them. Then okay, so I place that one aside. Then I now dismantle. Just dismantle. So this one is homemade. I like using this one because it looks like socket spanners, and it is able to hold very well. So I just remove, Don't worry about the kid. The kid is also helping me, and I'm just teaching him also, so that he will be able in the near future to do the repair. So you remove this one. So after that, now I need to, you see, so a bit like that. So you pull it like that. Then now you look slowly by slowly. Don't hurry, because you can easily make it crack. So you should not crack it. So you hammer as you remove it. So the reason as why I'm doing this one is because I don't have other tools. There are other tools which have been made, like for pulling. Now, because I don't have them, I've not bought one. I'll be buying one in the near future, so that I'll just be pulling it. So that's why I'm knocking, and as I'm knocking with a lot of care, so that I don't damage it. So you look as you rotate, so that it will come out very well. It's almost coming out. There it has come now. So that's the end shield. So whatever it was refusing to come is because of this bearing. So we have the bearing here, inside here, which is normally attached there. Okay, so now I go to the other end shield now. So the other end shield, I will not be able to use my improvised wrench, because of this pulley. It is too big and it will not allow that one. So therefore I will just use this other either fixed spanner or the ring. So if I use the ring, so I remove that one. So that will just remain hanging there. I remove this one also. That one. So I also pull it out. That one is now okay. So then I just remove slowly by slowly. I just remove it slowly by slowly, slowly by slowly. Okay, it is heavy. The most heavy part is this part. So this one is now the rotating part actually of the motor, and it's known as the rotor. So this is the rotor, it is the rotating part. So it is fixed by these end sheets with the bearing. So the bearing there is the one which normally keep it in position. So it is very heavy, and this type of rotor is known as squirrel cage rotor. So it's a squirrel cage rotor. It is the rotating part of the motor. So we put it aside. Then whatever is remaining now is known as the stator. So the stator is the part which is now carrying the wires. So those wires, you are able to see these ones. This one was for another motor. These wires, they were spoiled from another motor, and so we will be removing those wires if at all they are burned. So inside here now is the windings now. So we have the windings inside here. Windings now. So these are the windings, you see, and then this one is now the insulating cotton tape. So this person decided to use cotton tape in tying the windings together so that it will not be pulled out by the magnetic force. Inside here there is a lot of force which normally makes that rotor to rotate. So therefore you need to fasten so that they are very firm. Otherwise, if they are not firm, the forces inside here is going to make them vibrate, and when they vibrate until it breaks or it causes short circuit, and the motor will burn off. So these are now the windings. Okay, now so at least we have now removed. We have seen the windings. Also the other end there, you are able to see those windings also on the other end. So those are the windings, like that. Now we need to do the study now. I want us to study this motor very well. We want to study this motor very well. We have seen the windings. Then you need to see actually the way they are put inside. So inside this stator is slots. We have slots. They are grooves. These grooves that you are able to see. Close. These grooves. So these grooves are the grooves which normally carry the wires. So you put the wires inside those grooves as you are doing the winding. So therefore we study and see this motor the way it is. So before we do anything, what I want us to do is to check at the termination here. At times it could be the motor might not have burned when you look at the insulation of the wires. So the insulation of the wires, you try to look at them physically. You do physical inspection. So when I try to inspect physically, it is just telling me that it is just showing me as if there is nothing there. The wires have not burned. It's showing me as if the wires have not burned on this side. Then when I look at the other side also, so it is having a lot of dust because it is normally operated in a dust environment. So we just remove these insulations like that. Then we try to do the inspection. So when I try to look at the inspection, I am not able to see any wire which is cracked, and it's as if the wires are not burned. But now unfortunately there was open circuit in the starting winding. So because of that open circuit, it is well that we are going to remove some of the insulation here, so that we shall be able to see the termination where we are doing the termination from the wires inside there, the coils. So those coils after winding, so the ends will come to this termination. The ends of those wires now, these ends. So one of the end of the wire will come to one of the terminal here. The other end of the wire will come to the other terminal there. Then that will be starting winding. Then the running winding also will have the same set of wires, and one of the end it will come to this terminal, the other end will come to that terminal for that case. So therefore we are going to remove the insulation here, so that we shall be able to see actually what is wrong with this starting winding. Why is it that it is not showing us continuity?